Hello friends, this is Matt Domain. Today I am going to discuss about continuous function. So the any function is continuous. Suppose you have okay. Uh, Let me draw it nicely. Okay, suppose this is x-axis and y-axis. The function is defined from a to b. So this is the boundary for the function. Now if the function from a to b is like this, suppose this is continuous without any break, okay, then the function is said to be continuous. Now suppose, oh sorry, better to write this way. Okay, now suppose this is like this and this, so there is a point where the function is not continuous, so it looks like this, there is a break. Okay, so at this point the function is not continuous. Okay, so let me go to some details. First about the definition of the continuous function, and next how it works. Okay. Okay. So in our higher secondary, we used to learn a function is continuous if limit x tends to a is continuous at a, means limit x tends to a of the function is equal to value of the function. Okay, if we explain this line, this particular line graphically, I'll go to the mathematical definition in a while. So if we discuss this part on only for limit case, what happens? Suppose this is a function defined from say a to b. This is function fx. Now at c, the value of the function does not exist, but if we take the limit at x tends to c, means taking c from this side and this side, then the value of the limit is, suppose it is at this point. Okay, at this point, it means the value of the limit exists, but f of x at that particular point does not exist. It means it is discontinuous in that case. Okay, so if a function is continuous, then limit of that value, limit of a point of the function must be equal to the value of the function. It means this part must be like this, means f of c, this f of c must lie on the curve. Okay, f of c must lie on the curve. Okay, so if we go with a formal definition of limit, so first of all we take point c belongs to R, and a function f on say close interval a comma b and c belongs to, better you take in place of close interval a comma b, it is wise to take something else. Better we take let's on, make it general, on d subset of r. Okay, for close interval it will work anyway if it is work for the domain, any domain. So, and this c is a member of d. Now f is continuous at x equal to c if for every epsilon greater than 0 there exists delta greater than 0 such that mod of fx minus f of a is less than epsilon for all x such that mod x minus, or not a, it is c, sorry, we usually write a, so c is less than delta. So if c is a point in the domain of the function, then f is said to be continuous at c if for every epsilon greater than 0 there exists delta greater than 0 such that f of x minus f of c is less than epsilon, you have chosen epsilon, and this, that mod of fx minus f of c less than epsilon, this one holds for every x in the neighborhood of c. So to explain this, let me elaborate this part. Minus c less than delta, this implies that x belongs to x minus, sorry, what I am writing, c minus delta c plus delta. Okay, now the meaning of this one is this one. Okay, now come to this part, f of x minus f of c less than epsilon. This implies f of x belongs to open interval f of c minus epsilon comma f of c plus epsilon. So whenever this x belongs to this interval, my f of x belongs to this interval. Okay, so let me explain you in graphical format, then you will understand properly. Suppose this is my c. Okay, so this is c minus delta, this is c plus delta, and this is our function. It is quite big, let me make it like this so that I can. So this is my f of c. So what the theorem is saying, or the definition is saying, that whenever my x lies between this, within this interval, the f of c lies in a neighborhood of this point. Now think in this way: if this epsilon, this one is f of c minus, plus epsilon, and this is f of c minus epsilon. Now think in this way: if this is true for every epsilon, it means what, I can reduce this interval as small as I want. It means from the exact value and the value of the neighborhood, I can make as small as I wish. It means there is no break, or you can say gap, between the value of f of c and the value of its neighboring points. It means the curve at c is like, means continuous. Okay, not that mathematical continuous is a literal meaning of continuous, means there is no break. So this is all about continuous function. I hope you understood this one. Okay, bye.